Previously, we have talked about Gaussian elimination, a way of solving systems of linear equation using equations and also as matrices. This time, we're going to use another another way rather of solving systems of linear equation using matrices, and we're going to call it Gauss-Jordan elimination. Further, and later on, we're going to talk about a special system of linear equations called the homogeneous systems of linear equations. So, with Gaussian elimination, one applies elementary row operations to a matrix to obtain a row equivalent row-echelon form. In Gauss-Jordan elimination, we continue the process of performing our elementary row operations here. We continue doing that until we obtain a reduced row echelon form. And what is a matrix in reduced row echelon form? A matrix in row echelon form is in reduced row echelon form when every column that has a leading one has zeros in every position above and below its leading one. So say for example, we have a matrix here. Let's have this as matrix A, then I'm going to have 1, 2, 3, 4, 0, 1, 3, 5, and then 0, 0, 1, 6. So, we know that this type of matrix is in row echelon form because we have all leading ones here, and then the leading one on top of it is farther to the left hand side. Now, we're going to talk about this one, forming it or rewriting it further by elementary row operations to reduced row echelon form. So when we say reduced row echelon form, it's still a row echelon form. We have leading ones. If there's a row that is all zeros, they're all on the bottom. And the leading one of the row on top should be further on the left hand side. But if it's reduced row echelon form, let's change the color. If it's reduced row echelon form, the leading one in its column shall be accompanied by zeros. Zeros, zeros. So that means if it's reduced row echelon form, there is no other non-zero number in that column except the leading one. And as you can see here, since there's no more leading one here, rather, these can be the other non-zeros. And here, as you can see, because of these reduced row echelon form, we get an idea as to why the Gauss-Jordan elimination gives us immediately the answers. Because if this was, say for example, was your x sub 1, x sub 2, x sub 3, because of this row is immediately telling us that x sub 1 equals negative 1. This row here is immediately telling us x sub 2 is equal to 2, and this row here is immediately telling us that x sub 3 equals 3. Without any more going to back substitution. So Gauss-Jordan elimination gives us already the answers without going back to back substitution because we obtain a reduced row echelon form of our augmented matrix. So we're going to give an example of Gauss-Jordan elimination in the next video.